Alrighty, graders. So I have a lot of requests coming in for the function stuff. So this first set here really just deals with the order of operations and plugging in numbers. So for number 12, you have f of x equals 2x squared plus 3. So really, that you're used to seeing that look like this. Y equals 2x squared plus 3. So basically, they're using this term f of x instead of y just to keep kind of the letters similar. So if you look at this, find f of 6. Notice how this 6 is in the x's place. So basically, to figure out what this is worth, I'm going to take anywhere I see the x, so 2 times 6, and replace that x with the 6 that they want us to use. So 2 times 6 squared plus 3. So according to the order of operations, I do the exponent first. Obviously, if we were in the classroom, we would just use those calculators again, but I'm just kind of going pieces because I know we all have different calculators at home. So that would 6 squared would be 36. So 2 times 36 plus 3. So you got 36 times 2, that would be 72 plus 3 more, that's going to be 75. So find when f of 6 would be worth 75. You take 6 and plug it in for x. So 13, I think there was a typo on 13 here. So we're going to take this function, f of x equals x squared minus 8x, and we're going to rewrite this. Instead of saying this whole thing, f of x equals 4, we're going to say find f of 4. So it's kind of the same deal as what we just did there. So again, in x's place, we want to put a 4 there. So figure this out when you take 4 squared minus 8 times 4. So I'm just going to go through order of operations again. So exponents first, 4 squared, 4 times 4 is 16, minus 8 times 4, that would be 32. So then I just have to take and subtract the remaining numbers, and I would get, when I plug in 4 for x, f of x will be worth negative 16. On the next page, the range is basically looking at what we just did. If I take and plug in 0 to this function, what do you get out? So the range is also sometimes called the output. So what are the values that you get out when you put in a 0 for this function, when you put in a 3 for the function, and then when you put in a 5? So you have 3 different answers. So kind of like set this up here. I'll use R for range. When I plug in 0, what do we get? When I plug in 1, what do we get? When I plug in 5. So we'll kind of have a set of answers like they have a set of numbers. So D stands for the domain. When you input a 0, what do you get out? The range. So if I take this function, 2x plus 1, and plug in 0, so 2 times 0 plus 1, so that would be 0 plus 1 would equal 1. So when I input a 1, the output is, or sorry, when I input a 0, the output is a 1. And then let's change my colors here. If I input a 3, so 2 times 3 plus 1 more, so that would be 6 plus 1, that's going to be 7. And then change one more time here. If I input a 5 for x, so 2 times 5 plus 1, 10 plus 1 would be 11. So the 3 range values or output values I would get will be 1, 7, and 11. When I put in a 1, I get out of, or sorry, input a 0, I get out of 1. I input a 3, I get out of 7. When I input a 5 to the equation, I get 11 out. And on that same page, get this to turn for me. So I'm going to pause a sec and make sure I have this going. All right, so I think I have it fixed now. So now the next question is saying, which of these graphs is a function? So remember that vertical line test we talked about? I feel like it was a really long time ago. So basically something is a function if you can draw a vertical line, which would be an up-down line, anywhere on the graph and would only intersect the line that is drawn once, or the graph, I should say, that is drawn once. So like so I got these 4 choices. So in letter B, I can draw a line right here, and it's only hitting the graph at that one spot. It's only hitting it at that one spot. If I draw it right here, it's hitting it not once, but twice. So this guy is not a function because it fails the vertical line test. If I look at D, right, doesn't hit it all, doesn't hit it all, doesn't hit it all, that's okay. But right here on the line, it's hitting every single point on this line. So again, it doesn't pass the vertical line test. It hits the line more than once. So if I look at letter C, the same deal is going to happen. If I draw a line here, it hits twice. If I draw a line here, it hits twice. So as soon as I find a spot where it hits the graph more than once, it's not a function. So in letter A, I can graph it right here. It hits once, and I'm going to keep drawing lines. It doesn't have to be right on the coordinate either. I can do in between the coordinates. It only hits once no matter where I draw it. So A has to be my choice. So the whole idea of the vertical line test is that every input has one and only one output. So the graph version is that it passes this vertical line test. It does, when it fails, an input has two different outputs. If I look at this picture here, I'm looking at, so on choice A, is it a function? If I input a 1, I don't have an output, so we don't input the 1. When I input a 2, sometimes I get an 11, and sometimes I get 12. So we've talked about functions like a toaster. Every time I put in bread in the toaster, I will always get toast. Bread, toast, bread, toast, bread, toast. There's going to be a day where I put in bread and I get out scrambled eggs. So whenever you have more than one arrow from a single starting spot, the input, it's not going to be considered a function. This is like sometimes I get toast out, sometimes I get scrambled eggs. Can't happen. So if we look at letter B, sometimes when I input a 5, my answer is 20, but sometimes when I put in a 5, the answer is 30. That can't happen. It has to have one and only one answer. So C is even worse. Not only, sometimes when I put in an 8, I'll get a 1, sometimes I'll get a 10, and sometimes I get a 100. That also doesn't work. D is the only one. When I put in an A, there's only one arrow, you'll get a 4. Now when I input a B, I'll also get 4, but it's still only one answer for A and one answer for B. And then if I check C, C is also one answer, which is 16. So that's the only one where every input has one and only one output. So choice D is my function. 17, I know it starts on that page, but then choice C and D bump over to the next page. So now that we know based on that one, we're going to do the same thing here. Every time I put in a number, there's only one answer. So basically, I'm looking at X for the input, Y is my output. If I input a 2, I get an 8. Nowhere else is there a 2 happening. Anytime I put in a 3, I get a 9. 4, I get a 10. 5, I get an 11. That is a function, but we're looking for the one that's not. So that one is. If I input a -3, I get a 9. If I input a -2, I get a 4. Input 2, I get a 4. Input 3, I get a 9. Now these two have the same output, but there's only one answer for -2 and there's only one answer for 2. So that also is a function. For C, right away I'm noticing -2 shows up twice. -2, sometimes I get a 0, sometimes I get a -8. That can't happen. Same thing with 1. Sometimes I get a 2, sometimes I get a 3. This is not a function. Let's check the last one to be sure. 0, I'll get a 5. 5, I get a 5. 10, I get a 5. 40, I get a 5. So the output is always a 5, but every input has only one answer. There aren't multiple things for the same input. So C is the one that is not a function. So 18, which of these functions is not linear? So remember we talked about linear have exponents on variables that are either 0 or 1. And there is no variable in the denominator. So right away, if I'm looking at this, I'm looking for something with an exponent other than 0 or 1. And right away, I'm drawn to choice A, right? X squared makes this one not a function. B has a fraction, but y is to the first, x is in the numerator, and it's a 1. That's a function. Again, I got a fraction. Doesn't matter. If this is a 1, that's a 1. That's a function. And then choice D, I might have to do some distributing, but I'm still going to have an x, and I'm going to be to the first and a y to the first, so it's also a function. So 15, which of these graphs is linear? So the idea of linear, you have the word line in there. So which one of these is a line? Yeah, it's going to be choice B. It's the only one that's a line. These are curved, that's curvy, that's a whole circle, that's my line. All right, 16 was kind of our challenge one in here. Can you come up with the rule? What's the equation to get from x to y? So this is kind of like a guess and check right now. What do you notice about the numbers? Right, so I want to get y equals something. So what's there? So a couple ideas of what you could do. You could try to find the slope. You could find your x1, y1, x2, y2, find the slope and a y-intercept. You can also look for patterns in this. So I'm kind of seeing on the y's that there's some evens and some odds, some negatives and positives, but I'm noticing on the x's that they're all multiples of 3 in some form. So I'm thinking maybe do something with 1/3. So maybe if I take the x value, let's see, if I take -9 and divide it by 3, that would give me -3. But then how do I use that to get to -2? I'd have to add 1 to that to get to -2. So let me try that again. So I took the x and I divided it by 3 and then I added 1. Let's see if that holds true. So I have 3. So if I take 3 and divide it by 3, that's worth 1. And if I add 1 to that, I get 2, which is that one also works. So if I keep going, if I'm guessing and checking, I gotta check it in all of them. So if I take 6 divided by 3, that's 2. Add 1 to that, that's 3. That one works. So then 21 divided by 3, that's 7. Add 1 more, that's 8. And then I have 30 divided by 3, that's 10. Add 1 more, that's 11. So it did work. So it's kind of just looking for a pattern in the numbers to help me figure it out. So my rule would be take x, divide it by 3, then add 1. That would be the rule for this function. Take each x, do these rules to it to get your y. Now I'm also going to go back and show that same thing to you. I don't know if that worked. Show that again, but this time let's look at it in terms of slope and y-intercept. So I'm just going to write this here. Yep, I knew it was going to freak out on me again, so hold on a sec. Okay, so I'm back. It should be fixed now. So I want to show this to you again using the whole idea of slope and y-intercept. So we're looking at filling in to this guy, y equals mx plus b. So first thing I'm going to do is find the slope. So I'm going to avoid those negatives. This is going to be my x1, y1. Here's my x2, my y2. So slope is y2 minus y1 over x2 minus x1. So that would be 3 minus 2 is 1 over 6 minus 3, which is 3. So far I know the equation is y equals 1/3 x plus b. So this is where a lot of you tend to stop. You figured out that the slope is 1/3, but now we got to figure out the y-intercept. Where was the starting point? So all I have to do is pick a point in here. It doesn't matter which point it is. Typically we talk about avoiding that negative, so I'm going to go with 3, 2. So if I plug in 2 for y, 2 equals 1/3 times x is worth 3 for the minute, so I can figure out b. So 1/3 times 3, that's 1 plus b equals 2. So b must be worth 1. So the equation would be y equals 1/3 x plus 1. So I can find it using slope and y-intercept, or we can find it with that guess and check. Could I find a pattern in the table and to figure out my y and then continue that pattern and check it in all of them? And that's it for our function section. So stay tuned for more videos.